down and hit the ground in time t1, while the other two hit the ground in time t2. Find the height above the ground where the shell exploded. So we are discussing now vertically. So this is the explosion, this is the explosive. So let this be ground. So here the explosive is projected into three identical fragments. So 3m, you take in this, it's projected vertically up, that one. So then somewhere here explosion occurs. Explosion occurs. Then due to explosion, what happens? Three fragments will come. So now one fragment will move vertically down. The other two fragments must move like this, no? Now, sir, why you are picking up situation like this? At highest point, they're exploding, not at something, at highest point. So at highest point, what's the state of the explosive? Just before explosion, instantaneous rest. If one moves downward, so what should happen? So the other things what happen, I'm assuming like this. So can I assume this instead of like this, both vertically up? It's left to you. So here he has not said any condition, so it will be safer to assume. But they can move in a plane also. Okay, that one I'm just giving some information, so they can move in a plane also. So let me assume like this. So this will be V2. This will be V3. They can move in a plane since he didn't cite any condition, so therefore I'm just assuming vertically up. So this is what is asking, where that explosion occurs. So what is the time taken by the one and hit the ground? So what is the state of one? Should be at rest or should have any velocity or should be at instantaneous rest during explosion? Should have some velocity, no? Otherwise momentum will not be conserved. And what about 2, 3 fragments? They should have velocity directed upward and V2 equal to V3 equal to, both should be equal. Any reason for that? Both are having same mass. So I'll apply conservation of linear momentum. Initial momentum equal to, as a net force on system along y-axis 0. Initial momentum 0. During explosion, it was at instantaneous. Finally, mv2 plus mv3 minus mv1. So therefore v2 plus v3 equal to v1. Let v2 equal to v3. So let it be equal to v. So therefore 2v equal to v1. How to proceed now? So what is the time taken by the this will go round and it will strike the and this will just descend vertically down. So you take like this. So this is A, B, C. This is A and this is D. Time taken to move from A to D is what? T1. TABC is what? The T2. Any equation can we write? H equal to V1 T1 plus G T1 square by 2. This is for what? For the first fragment. For second or third fragment, minus H equal to V2 T2 minus. Now, why this condition like this? Second or third fragment, when it moves from A to C, no? So how G will be acting? Opposite to V3. And what is the displacement is also opposite. So what is the question given for us? We should relation between, find the height above the ground where the shell exploded. So what are unknown things? That V1 and V2 are unknown, no? So what we have is V2 equal to V and V1 equal to this one. Substituting this, H equal to V1 is how much? V by 2 T1. And V2 is equal to VT2.
So V1 is equal to 2V.
V1 equal to 2V. Yeah, this one. So what is the only unknown thing that V can be eliminated, no, from this equation? Solving this equation 3 and 4. I'll get expression for the H. Okay, this I'll write it, check calculation later on. No? Now same questions are like if it is not at the highest point, it exploded somewhere when it's moving exploded. How to manage that problem? You may ask question like this also. When it is somewhere in between when it's exploded.